Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving push dominoes. So the problem states that we are given a string named Dominoes, and there are three possible letters that can show up in that string. If it is L, then that means the domino will be pushed to the left. If it is R, then that means it will be pushed to the right. And if it is just a dot, that means it has not been pushed. However, it can be pushed from the right side or from the left side, depending on what's on the right and what's on the left. And if it feels a force from the right and the left, then it will stay still. And one thing that we should know is that for this question, the amount of force coming from the right or left does not matter. So like right here, it doesn't matter if there's two forces from the right and only one from the left. All that matters is the timing. If the right side reaches the domino first, then it will be pushed to the left. And if the left side reaches the domino first, then it will be pushed to the right. It doesn't matter how many dominoes on the left. So if you look at this example, obviously right will push right, right will push right, left will push left. And since this is right in between, the right and the left will reach at the same time, so it will stay still, so we keep it as a dot. So now that we have seen some examples, let's get to how we can solve this problem. Before we go in detail, let's look at all the possible cases of a dot. So obviously, if nothing is pushing it, it will stay still. Nothing is pushing this, so it will stay still because this is falling to the left and this is falling to the right. And this will stay still because it is two dominoes away from the right side and the left side. And this will fall to the right because this domino will touch this first before this domino touch it, and that's why this one will fall to the left because this domino will touch this first. So basically, the R in the string will always be returned as R in the resulting string. The L's will always be returned as L. And for all the dots, we need to look at the nearest R to the left that does not have an L blocking in the way. So let's say if there's an L here, then this R wouldn't count. So the nearest R to the left without an L blocking in the way, and same for the nearest L to the right without an R blocking in the way. And where the dot will lean would be if it is closer to the nearest L to the right or the nearest R to the left. And if it's equal distance, then it will stay still like this one right here. And if they have neither an R to the left nor an L to the right, then it will also stay still like these two examples. And if it only has an R to the left, then it will lean to the right. And if it only has an L to the right, then it will obviously lean to the left. So what we can do is we can calculate the force going to the right and to the left at each place and see which is the greater between the two. And if they are equal, then it will stay still. So what we can do is the force for R will always be the length of the string, and the force for L will also be a length of string but in negative. And the strength of these dots will depend on the distance from R. So for example, right here, the strength of this would be 8 because the length is 8, and the strength going to the right would be 7, and the strength coming from the left would be 7, 6, 5. So it would be -5, and 7 at -5. Obviously 7 is greater, so it will fall to the right. And obviously right here, it would be -7 for the left and 5 from the right. So it will lean to the left, and this, it will be 6 and 6, 6 plus -6, which equal to 0. So if it's 0, it will stay still. And these two will also be 0. So what we can do is we can initialize right force, left force, and forces to zeros times the length of the string. And the right force will be the forces going to the right. The left force will be the forces going to the left. And then we will add them to the corresponding index and then put it in forces. And then we will go through forces. If the element is positive, then we will add right. If it is 0, we add the dot. If it is negative, then we add left. So let's go through this example real quick. So as you can see, we have R right here, length of 14, and 13, 12, 11. And then we come to a left, so we just put a 0 here, but then here's another right one. So 14, 13, 12, and then left. So we stop it here, and these are all zeros, and these are zeros. And then now we look at the left, but we will do it backwards. So we first come to first L, -14, -13, -12. For the next two dots, come to an R, so it's a 0, and we see an L again. So -14, -13, -12, -11 for these. And then we come to an R, so we put a 0, and then here's a dot, so another 0, but now it's an L, so it can be -14, and then -13. So now we will add what we have here to here, and this will be how the array looks like. And then now we can add to result. So just to save some time, the resulting string will look like this, because negative, negative, so LL, 0 dot, positive, positive, RR, 0, so dot, 2 negatives, so 2 L's, 2 positive, 2 R's, 2 negatives, 2 L's, and then 2 zeros, and 2 dots. So the time complexity would be O of n, where n is the number of characters in the string, because that's the number of elements that we will look through. And the space complexity would also be O of n, because the forces array will take up n space. And by the way, when I code out the problem, I'm not going to have a right force and left force. I would just add them to the forces array right away. I just laid out the right force and left force on purpose, so that way it'll be easier to visualize. But either way, it would be O of n. So now let's get to the coding part. So first we'll set up forces. It'll be 0 times length of dominoes. Then we will set force to 0, and then we will first look for the forces leaning towards the right. So for iron range length of dominoes, and if the letter is R, then we would first set force to the length of dominoes. And if it is L, then we will set it to 0. Set to 0. Otherwise, then we will take the force minus 1 or 0, depending on which one is larger. And then finally, we will add that to that index in the forces array. And now we will do the opposite, which is look for the left force. So remember, we need to look backwards for that one. If dominoes of I is equal to L, we will set the force to length of dominoes. And if it is R, now we set it to 0. And otherwise, if it's a dot, then we will take the maximum of 0 or force minus 1. And then we need to subtract by it. So now we can add them to the resulting string. So we'll initialize the resulting string as empty, and now we'll look through forces. We can just do for f in forces. If f is 0, then we just add a dot. And if it is greater than 0, then we add R. Otherwise, we add L. Else result plus L, and then we can return result. See if it works. Okay, perfect. Hope this was helpful. Thank you for watching. If you have any other questions or comments, feel free to leave in the comment section, and I hope to see you all again soon.